This week's episodes were brought to you by the generous support of Petrie Michaela. Hey folks, Quilly18 here, and welcome to another episode of our C# tutorial for complete beginners. Last episode, we sort of introduced the concept of classes and did this unit class that is shared by both player and enemy type units. But it's not a very clean implementation. It's not encapsulated. We're going to organize this better and move towards what is really the whole idea behind object-oriented programming as much as possible. In particular, excuse me, apparently I'm losing my voice, oh my god. In particular, these public fields here, X, Y, and unit graphics, we don't want them to be public. We don't want them to be modifiable outside of the unit class. Not directly anyway. And why is that? Well, right now, we can set the X and Y coordinates of this unit, and then we call this draw method, which sets the cursor position to the X and Y coordinates, and then draws out the unit graphic, right? If we need to reference what had happened, start without debugger, it's my first build of the day, so it'll probably take longer, right? It prints this @ symbol and this X here for the enemy. But what happens if we give this invalid information? What happens if we set the player's X position to, say, -10? -10 would mean it's off the screen to the left. So if we try to run this, we get an error. We get an error over here. Because, specifically it happens on line 17, unit.cs line 17. If we take a look, that's right over here. It's trying to set the cursor position to a negative X coordinate, and that throws an exception. Inside of set cursor position, they check for that and they say, well, this doesn't make any sense. That's not valid. All we can do is throw an exception and freak out. So it means that in our greater program, we always have to make sure that the player's X and Y are valid. And really, that's not the job of the main program. Units should look after themselves. And so that's what we're going to do here. And the way we're going to do it is we're going to change these three variables here, these fields that belong to the unit class. We're going to change them from public to private, like this. So this is the like sort of security level of this field. This is the access level of this field. We're being told it's redundant. Technically, if you didn't specify one at all, by default, I believe it would be private, but it's always better to be explicit. So these are now private fields. And now if we were to try to compile or run, either way, right, we build this, we get errors. That's because our main program is now no longer allowed to touch those numbers at all. See, unit.x is inaccessible due to its protection level. It's at a private protection level. No one from outside of the unit class can fiddle with those bits. Now, of course, we still need to set those somehow initially. We just want to make sure that when they get set correctly. What I'm going to do for now is I'm actually going to just get rid of the unit graphic line, and we're just going to focus on the bit where we set coordinates. So if we can't write to the X and Y directly anymore, how do we set those values? Well, there's, like in everything in programming, there's more than one way to do it. One way we can do it is by providing a setter and a getter type of function or method to our unit class. For example, so we've got this draw method. That's great. Let's go and make another one above that. We're going to make a public method, which returns nothing. It's a void, and it's going to be called something like set position. Okay? And what it's going to do is it's going to expect two parameters. It's going to expect us to pass an integer called x and another integer called y. And what this is going to do, it's going to set our x and our y to the values that get passed here. Now you might be like, well, okay, hold on. There's a variable called x over here, right? And another one called x over here. Won't that get confusing? Like, how can I set x is equal to x? Well, we mentioned it a little bit last time, the this parameter here. Because this is confusing, right? We don't know which x is talking about. If you just use an x by itself, what it does is it tries to look for the most local, the closest version. So in this case, x refers to the x here that exists only within the scope of this function. But if it were to not find a variable, for example, if we reference unit graphic and, set it to some value, right? Then it looks first within this block. It doesn't find it there, then it looks within the class and would therefore find it. So if we want to set the x that belongs to the class to the value that gets passed as a parameter here, we could say this dot x is equal to this, and this dot y is equal to that. Okay, which means that now, over in our main program, instead of setting things this way, we would instead say something like dot set position, what do I have, 10, 5? There we go, something of that nature. And the same thing for the enemy. So I guess enemy unit dot set position. I'm going to set it 20, 17, and then we're going to remove this reference. So now, if we run this, should compile okay. Start without debugger. Why is it blank? Did I forget something over here? Oh, we're never actually setting the unit graphic anymore. Right. Let me just set a default value over here to the unit graphic and try to run that again. There we go. Okay. So we're back to the old thing, other than the fact that this is not a capital X, but that's okay. But the positions are the same as before, but we're setting it this way. Now, it's still, at this point, we can still set an invalid value over here. And if we try to run this, again, we get an error. Because while we do set the X and Y coordinates via this method, we're still not checking. We're not doing any sanity checking. So then the question is, okay, so how do we do that? Again, lots of different ways to do it. One of the big questions is always, where do you check for these? And also, what do you allow? So let's, first of all, let's check to see if the X and Y coordinates are valid. So we're going to do this. We're going to do an if. So if, what does it mean if it were valid? Well, if X is, well, if it's greater than or equal to 0, then that's valid. Okay. Also, it needs to be less than the largest possible X allowed. What is the largest possible X allowed? Well, the largest possible X is, I'm going to explain this in a second, is if X is less than console.window width. Let me close this up first. We're not done with this, but let me get the structure kind of in place here and explain what's going on here. So we have to make sure that X is greater than or equal to 0, because 0 is the leftmost column, right? Again, you can think of it as an offset from that leftmost column. 0 is fine, it's the leftist mostest column, whereas what is the rightist mostest column that you can be in? Well, it's equal to the console's window width minus 1. By default, your window should be 80 characters wide, which means where X is equal to 79 is the furthest to the right you can be, because 0 to 79 is 80 different positions. And so console.window width by default will be 80. So we check that X is less than this 80, which means that the largest allowed X is 79. That works out. So if X is between here and here, we're good. So what is with this double ampersand symbol? Well, of course, I mean, you're used to writing like an ampersand as a, that's the short form for and, quite commonly in English writing. But just like how you need a double equal sign in your if, right? We talked about that. Like if 1 is equal to 2, you need a double equal sign because a single equal sign does more stuff, right? The single equal sign is the assignment operator. A double equal sign is the comparison operator. Well, likewise, a single ampersand is part of the bitwise operators, which is beyond the scope of this particular set of tutorials here, but this does kind of more stuff. Whereas if you're trying to do comparisons inside of an if, what you're always trying to think is almost always you're using a double symbol. The only exception is like the less than or the greater than symbol. So this is a Boolean operator that makes sure that this and this both return true. So X is greater than 0 will return true or false, or evaluate to true or false is another way of thinking about it. Where an X is less than window width will evaluate to true or false. So the AND operator checks to make sure the left side is true and the right side is true. And if that's true, it returns true. So we can, it's very classic in like programming tutorials to end up with these charts where something like true and true, it will resolve to true, whereas true and false resolves to false, and false and true is equal to false, and of course false and false resolve to false as well. So that's the AND operator. There's also the OR Boolean comparison, which is these vertical pipe symbols, and I realize it's a little bit, okay, how is that or? Well, it is, because of reasons. So there's, again, 4 possibilities. I never put in the last one. There's 4 possibilities, though. So with or, it just says, this is note, in English, when you say, do you want Coke or Pepsi? It's expected that that's an exclusive or. You either want Coke or you want Pepsi. But in computer languages, by default, it's not an exclusive or. So if you want either Coke or you want Pepsi, then you just say yes, right? As opposed to asking which one. So here, if the left is true or the right is true, we return true. So true or false, well, this is true because one of those things is true, and false or true also comes out to true. When you're using ors, the only way to return a false is if both sides are false. And there's also a side effect in computer programming where it sort of doesn't tend to check both sides. No, you know what? Forget I said anything about that. Not important. Okay, so we are now checking that both ends of the x are valid. So then we also need to make sure that y is greater than or equal to 0 and y is less than console.window height. And because I have my font set to be quite large, this starts to scroll the view. So what we can do to help this is, because white space doesn't matter in computer programming, we can do this. Okay, this is exactly the same statement, right? X is greater or equal to 0, and X is less than window height, and Y is greater than or equal to 0, and Y is less than window height. I said height twice, but anyway. Then this, because this is the entire if check. This is what we're verifying here, and then we execute this block. So X and Y are both valid. So update them. Right, so now, if we look here, right, player unit.set position, I'm still going to try to set a negative X. We're going to run this. And now we don't get a crash, but what it does is because we've passed it invalid coordinates, it's not setting us anywhere. It's just leaving us at 0, 0, which is our current default value. Now, this is referred to as failing silently, where, like, if something's not valid, you just don't do anything. That's often not the best way of doing it, right? Right now, we're just failing silently. The other ways of handling it, instead of failing silently, consider, 2 other possibilities? I guess so. 2 other possibilities. Option 1, try to fix the input, i.e. something like, if x is less than 0, then set x to be equal to 0, right? So if you're trying to go off the screen to the left, we'll just set you to be on the screen in some sort of valid way. So that's sort of option number 1 to fix it, which might be good, might be bad, depends on your flow. But usually, option 2, fail loudly. Usually this is the best option. Instead of failing silently, or instead of trying to fix the output, fail loudly. Let the program know that something went horribly wrong so that you, as the programmer, can sort of try to fix it in a more intelligent manner. So something like, if x is less than 0, then freak out and put up some kind of error message. In this case, what you could do, and we're not going to talk about exceptions very much. We dealt with it slightly in the I guess it was episode 2, where we were parsing an integer, and we were trying something and then catching an exception. Well, we can also throw exceptions. You would throw a new exception, and now there's a million different types of exceptions. This is the generic one, and it happens to accept a string in here, right? We could say something like invalid x coordinate passed, right? And this would crash your program with an error message, but it means that you can then know when that happens and be like, well, why does that happen? And actually, the crash message gives you a trace log. So let's say, so here we're only going to set x and y if they're valid. And then if x is less than 0, we're going to throw an exception, which is entirely what tries to happen here. So if I go and run this, say without a debugger, that's fine. You see we get our crash, but we get the exact line where it happened. Unit.cs line 33. Now it crashed here. This is where the exception was thrown. It didn't crash. We threw an exception that wasn't handled, so the program quit, right? It happened here on line 33, but most importantly, this function here, this unit.setPosition, was called at dodgegamemain.main on line 13. So you get that information. You say, okay, yes, it threw an exception here, but what was the root cause of this? Okay, it's in dodgegamemain line 13. It's right here. Oh, we try to call it with a negative. What are we going to do about that? And then you can start to think about it. For example, if our player moves around based on keyboard input, well, then what we probably want to do is if the player is hitting the left arrow key to go further left, but the player is already on the leftmost side, then we probably just want to ignore that key press and not let the player go any further to the left. So it's sort of the responsibility of the keyboard handler, perhaps, to make sure that that input is okay. Whereas if it's the enemy trying to go out of bounds, well, maybe the enemy AI function needs to check for that. Or maybe enemies simply die when they run out of bounds, right? If this is a side-scrolling shoot-'em-up game, right, where you have the spaceship on the left side of your screen and enemies come in from the right side of your screen, normally you shoot them and they're trying to shoot back, but they're scrolling from right to left. When they hit the left side of the screen, you just remove them. The enemies are supposed to stop to exist. So then you start incorporating that into your logic. And so this function here, its responsibility is just to make sure the x and y are valid and freaks out if it's not. And then the thing that sets the x and y has to think about, like, well, what is my correct behavior? How do I want to stay within these bounds? But it means that you can catch these errors and in a much better way. And you know exactly, this error gets thrown exactly when someone sets something invalid, instead of sometime later when we try to draw the coordinates and all of a sudden we've got an invalid x when we set cursor position and it crashes here, but you don't know why it crashes here. I mean, it crashes here because x is invalid. But when did x become invalid? So this makes sure draw can 100% know for a fact that x and y will always be valid coordinates because we have this gatekeeping little interface over here. Now, in practice, this flow here where we check to see if x is valid and then set it, and otherwise do fail or do something like that. This is actually the inverse of how you would normally do it, by the way. Normally what you would do is you would have your freak out at the top, okay? And then with the freakouts out of the way, so in fact we can do that quite easily, right? I'm going to copy this block. This was to check to make sure it's valid. Now instead I'm going to check to see if it's invalid. If x is less than 0 or x is greater than or equal to window width, or y is less than 0 or y is greater than or equal to window height, we throw an exception. And then we can say, if we get here, everything is awesome. And then we just set it. This is also, while it's sort of trivial in this particular example, right? What's nice about this is you can have multiple checks. You can check like one set of things for validity, then another one, then another one. So you have a series of checks for validity, each one of which, if they fail that check, you freak out and throw an exception or, update the values or do some damn thing. That's all fine. And then just when you get to the bottom, well, we've passed all the checks, so we just set the value and we're done. So we've got a get position. We have a set position. We probably also want to have a set. God, I keep inverting it. We have a set position. We probably also want to have a get. So we could do something like a public function that returns an integer that is called something like get x and simply return x, and another one for get y. Now, it's a little cumbersome here that you have one called set position and then get x and get y. If you're working in Unity, then because your coordinates are actually stored in an object called a vector, which contains x, y, and in fact z, all in the same class, you can just get position and it returns a vector. Here we don't. We can make a custom class though that just holds the pair of x and y as a single class, and then you can pass those values back and forth. That's another option. So this sort of setter function and getter function is a very typical thing to do, and it's encapsulating the x and y so that they are protected from manipulation from outside this class. This way, our class is just responsible for doing the right thing all the time, whatever that is. And in this case, the right thing is freaking out if we get invalid output or input. So x and y are always guaranteed to be valid numbers. Now, there's another way to do this, okay? Rather than use these set and get functions, you could sort of use, they're sort of implicit functions. They're accessors, they're setters and getters, accessor functions. So I'm going to show you that now. So this is fine. Nothing wrong with this whatsoever. But there's another kind of cool way of doing it. What we can do is we're going to change x over here to be public once more. You're going to say, well, we just went through this whole thing saying that this is a bad idea because other people from outside the program can set it. Yes, that is true. So now I can go back to saying player unit dot x is equal to -10, right? Let's hide that. Let's put that away. And we can go back to doing this, which means we can set invalid values, which means we'll get a crash when we try to draw it. But rather than being, this is currently a field, right? It's an exposed variable. Instead, we can have it be what's called a property. And basically what we do, it's going to look a little weird. We're going to define a block here, and we're going to say get and set. So this, right now, will still behave exactly the way as if it were, say, let's compare these two. Okay? This x and this y currently will still behave the same from outside the program in that, or from outside the class, in that I can say player unit dot y is equal to 5. They're indistinguishable from the two. But technically, this is a property which has a getter and a setter. And what's interesting is you can set different permission levels for this. By default, this is all public, but I could say that setting the x is a private job. You can't, the only thing that can set the value of x is the unit class. So now if we check here, we should get an error. You're not allowed to set the value of x. But what's interesting about this particular configuration is you could read the value of x. All right, so I can't set x, but I could do something like if player unit dot x is greater than 20, then, do something. This is okay. So now, again, we're forced to use set position if we want to set the x, but reading it is very simple. We don't have to have get x and get y. That being said, you don't tend to mix these two. If you have a setter function, usually you will also have associated getter functions, and you won't necessarily see this particular construction. Although in this case, because set position sets both x and y together, it might be allowed. Anyway, I'm sorry, I'm rambling. Okay, that's interesting in that only things inside of unit can now set x, but anything outside of unit can still get the value of it by going .x. That's kind of cool. Can we make it better? Yeah, we can actually. We can take this one step further. First of all, public properties, by convention, you tend to use capital letters. Whoops, there we go. Capital letters for public properties like this. We could go back to having unit graphic, in fact, be a public property. And again, you would typically use uppercase letters for this. Typically use uppercase letters for public properties, lowercase starting letters for private stuff. We'll talk about protected, which is another access level soon as well. It's got its own other things. And then there's a convention also for an underscore, which actually we're going to talk about in just a moment over here. But yeah, so typically you would do this for your public property. Now, this obviously is going to cause us a lot of errors over here. But what we can do is this. So we can say we've got this public property x that anyone can get or set. But what it's actually doing behind the scenes is it's actually interacting with a private x like this. The underscore here doesn't do anything for programming. This is a perfectly valid variable name. Underscore x is a perfectly valid variable name. But what it is, it's a hint to the programmers that you should never fiddle with this directly. Instead, here's what's going to happen. When you get the value of x here, what it's actually going to do is get is sort of like a little function that will return the value of underscore x. And set over here instead will set x to whatever value x gets set to. So x doesn't exist. X does not actually have its own memory assigned to it in any way whatsoever. Instead, this x property is just the public interface to this underscore x value. But it means over here, so while lowercase x doesn't exist, I can check uppercase x, and I can also set uppercase x over here. And just like I can set uppercase y over here. So I can set these values over here, but what it's secretly doing is setting this underscore x. And what's the deal with this? Well, that's when we can do some validity checking. So before we set this, we are going to check what value, what value is getting passed here. If the value that we're trying to set this to is less than 0, or the value we're trying to set it to is larger or equal than the window width, then we will once again throw an exception. And then if we get past here, we can set x to the value. So we're gonna try to set, when we try to set x to something, it runs this. We'll check to make sure it's valid, and assuming we get through that check, we will set underscore x. So that's what this is. So this is where the value of x is actually stored. The way the rest of the program interacts with x. So what's the upshot of all this is now we don't need this set position code at all. In fact, I'm going to get rid of this. We don't need the get x and get y. We're going to get rid of all that. And now, from outside the program, we can just set x to do things. So there's no set position anymore. Let's get rid of that. We can just try to set x. So if we try to run this now, we can set x, set y, we can compare it, we can do whatever. We try to run this. We will, oh yes, draw. There's no dot lowercase x. So we will just read uppercase x, uppercase y, and I think unit graphic as well needs a uppercase u. There we go. Let's try to run that one more time. We're getting an error, which makes sense because we've got an invalid x coordinate pass. We're still trying to set x to -10, and we are catching that in our getter and setter. Again, we could change this behavior. Instead of throwing an exception, we could either ignore this set request completely. We could have it try to fix the value to be within valid bounds, or my personal favorite, and this is almost always a good idea, throw a loud failure message so that you as a programmer know that you screwed up somewhere. And again, you get that trace. And it's, in fact, it's even nicer if you're running it in debug mode. When it hits that error, you actually get it inside of Xamarin Studio over here. So your program sort of pauses a little bit here while this exception gets thrown, and it actually highlights it in the code. It shows you the call stack over here, so you actually see the order of things. So currently we're in set x, but we were called from the main function over here. And in fact, in more advanced programs or bigger programs, this call stack might be like 10 functions deep. So you see the exact sequence that led you to this situation. And not only that, but over here you can see the local values. You can see that value is currently -10. I mean, I realize it's going to be really hard to see on YouTube, but the value, so this variable basically called value, currently holds a value of -10 over here, which is like, oh, well, that's what the problem is. And then you can go back and say, so how did this happen? Double click on here. It sends you to exact line. Oh, here we're trying to set it to something that's not right. Huh, herpaderp. Okay. Yeah, that won't work at all. So let's go ahead and just kill this. And then, oh, I meant to set this to 10, not -10. So now if we try to run it, there we go. This is the monster character here because we're not setting its position anymore. So this is the player here. And if we try to, once again, set the enemy unit, so we're not going to have set position, but I can say enemy unit dot x is equal to 20. And enemy unit dot y is equal to 17. There we are. And yeah, run that. There we go. That looks better. Still the wrong symbol, but that's okay. So that's one thing. Now, depending on what you're doing, you may or may not still want to provide this sort of public interface for some of the properties. Yes, sometimes, no, sometimes. For example, it's entirely possible we never would want X and Y to be set directly, in which case we would not set up this public interface at all. Instead, maybe we would want to do some sort of set of functions like you know, maybe you'd want a function that's something like move left. You know, public move right. Maybe this is the only way in the end you would want the outside program to interact with the sort of x, y coordinates of your characters. In which case, that would be a really good place, a really good example of having the public property with a public get, but a private set, so that the rest of the program can still check the value of .x, but can't ever set it in any way whatsoever, and instead has to interact with these sorts of things. That's a very common thing to do. We're going to look at one more thing in this video before it gets overly long, and what we're going to do is talk about constructors, which I think I vaguely, briefly mentioned at some point. A constructor is a special type of function here. And we talked about it briefly because I think when we tried to set, like, create the new random or something like that, basically a constructor is a function that automatically gets called when you create a new instance of an object, of a class. So here we're creating a new unit, and we've got these parentheses over here as if we were making a function call. And in fact, what this is the parentheses here, what values you can stuff in here. You know, you can pass things, right? Let's say we want to create a new unit at position 10.5. Instead of setting it here, we could set it as part of the construction of the object, as part of its instantiation. But to do that, we would need a constructor that accepts these values. Right now we've got an error because unit does not contain a constructor that takes 2 arguments. So first of all classes, if you don't specify any constructors, all classes automatically get a constructor that looks like this. It's an empty constructor. It's by having it be public, it means that, yeah, empty constructor is redundant. That's fine. That's fine. By having it be public, it means that anyone is allowed to instantiate a copy of unit. And by having it be empty over here, it means it doesn't need any properties, or doesn't need any parameters, and then right now it doesn't do anything. But it might. For example, here we set the default value of unit graphic by doing this. I didn't really explain it at the time because I was just trying to move along. Here we set the default value of unit graphic by doing this. Instead of doing that, what I could do is in the constructor here, I can say, let's make sure that unit graphic is set to this @ symbol. You know, and explicitly, just to make it clear, it's this .unit graphic we were setting to that. So that's perfectly fine. So this would be a default constructor. If we want to be able to do this, where I pass the initial coordinates, I can have another constructor, public. Note that constructors don't have a return type. They don't even return void. They have no return type whatsoever. And in fact, if you try to set one, it won't work. So we can say here that unit, we also are able to construct a unit by passing an initial set of coordinates. So we can, again, we might want to set the unit graphic to something sensible by default. And then we want to say, we're going to set our x to be equal to this, and our y to be equal to that. Notice I could, because I'm working inside of unit here, I could directly set the value of this private _x. But again, the underscore is there to remind you that you shouldn't set this directly. Why? Because the public setter for x does the sanity checking for us. While here we do have the ability to set _x directly, you know, to some value. It also means we have the ability to completely goof things up, which we don't want. So let's go ahead and do that. So there we go. So we have 2 constructors. And this is something we haven't looked at yet. But in, well, quite a few languages actually, but specifically C# here, you can have 2 functions with exactly the same name as long as they have a different signature. That is to say, they have a different set of parameters over here. As such, C# knows which version of the constructor you want to call. Here we're calling the constructor with no parameters. So it will run this. Whereas here we are running a version of the constructor that has 2 integers. Therefore, it knows we want to run this one. And in fact, it would even be smart enough if we had another one, public unit string s. Like even this one, let's say it took 2 parameters. This doesn't make any sense. This is a dumb example, right? But this takes 2 parameters. If we pass it, if we try to call this like this, again, it knows, it has a very distinct signature. C# compiler will know we specifically want to call this version. It's got 2 parameters, a string and an integer. This is a string and an integer. Done. Cool. I mean, that's a terrible example. There's kind of pointless, but we can do that. The other thing you can do with functions, and you will see this sometimes, so it's important to know, is you string, we're going to call it UG for, well, I'm going to call it unit graphic like this. You can set a default value over here. So we're going to set unit graphic like that. So what this means is we can call this function, or this constructor, and we can pass it all three parameters. I can do this. I can say unit is going to be a 10, 5, and its symbol is going to be, I don't know, an A over here, or P for player, there we go. So I can pass it that third parameter. That's fine. Everything's happy. If I try to build this, yep, everything is groovy. Or I can leave it off. And what will happen is this is still perfectly fine because it still knows that you can call this one here. You have to give it an X and a Y. That's required. But if you don't pass it a third parameter, it'll automatically set the parameter to this value over here. Now, in this case, this would get a little confusing if we happen to have another constructor with this signature here. Right? If I tried to do, type properly, if I tried to do this in build, really? Build successful? Really? Oh, I was sure it was going to complain because it wouldn't be able to tell the difference. I'm assuming that this is actually going to run this version here. I'd actually, I would be much happier if this threw an error. This does not throw an error, really? Ooh, I don't like that. Because it could be very confusing. This, I'm assuming, is going to run that. Wow, that makes me very unhappy. I would like it much better if the compiler threw an error here and said, well, I can't really tell if you want this or if you want this. Now, a lot of times, rather than set this way and have a default, you actually might be much happier in having these three versions like this. You can call it empty, in which case X and Y just stays at its default, which of course is going to be, here, I can make it explicit. X is actually going to be set to 0. I mean, this would happen anyway. This is redundant, but let's be clear. And then in the second version, what we do is, and I'm going to keep the same order over here. In the second version, what we do is we set X and Y based on this, and then set unit graphic based on something that we feel is a reasonable default, and so on and so forth, right? This could be fine, and then no matter which one you call, the right one happens. Another thing that's quite common, though, is you call another version of the constructor or another version of the function using these parameters, right? I think I'm getting a little far, but you can string them together. Anyway, we're not going to use all of these. What we are going to do, tell you what, I'm going to use this one here, where you have to pass all three values, which is great. I'm going to get rid of these three. So now you have to pass an X, a Y, and a unit graphic to construct a unit. All units, to just instantiate a unit, you require this. And actually, that's very explicit. Here, if I tried to compile, I would get errors. Two errors, because here, there's no version of the unit constructor that just takes in 2 integers. Instead, the only one that exists is one that requires all 3 of these. And it's also worth noting that the empty constructor no longer exists. If you don't put any constructor whatsoever, C# automatically assumes a default constructor that is completely empty and does nothing. But as soon as you have any constructor whatsoever, the empty one is no longer valid. So you're no longer able to instantiate an enemy like this. Instead, you have to instantiate it by giving it some coordinates and passing it some sort of symbol. So now, we don't have to set the player's position. We don't have to do anything like that. We instantiate the player unit at a certain place with a certain symbol. We instantiate the enemy unit at a certain place with a certain symbol. We can change it if we decide later on that this is no good. We're allowed to do this. And what's nice about it is our setup will automatically verify that this value is valid. And if it's not valid, it will freak out and yell at us so that we can fix the problem with our program. But if we try to run this, we are back, well, to literally where we were at the start of this particular tutorial. But look how simple the code here is. We went and did a bunch of error checking and configuration and stuff in Unity, or in the unit class. And I did a whole bunch of functions that went then deleted. I'm hoping that's not sort of confusing. The getter and setter functions, perfectly fine. You can use that methodology. That's totally okay. Or you can define these properties like this. It ends up looking a little cooler in the code, right? It's like, it's nice to be able to say enemy unit.x is equal to 10, as opposed to enemy unit dot set x to 10. I mean, functionally, well, I mean, this is an error right now because we don't have a function. We don't have a method called setx. But functionally, they're exactly the same. It's just really nice and convenient. It looks a little bit better, I think, a little simpler to what's going on. Clearly, we're setting this x property to do that, and that's groovy. But you might have different preferences. Also, if changing x is actually going to have a bunch of side effects. That's the other thing. Like right now, we're just using this property to do some sanity checking to make sure that x is in a valid range. But there could be a side effect, right? Like after you change x, maybe additional things happen. Additional things might happen here. If we're standing on a platform, maybe we need, if we're now standing on a platform, maybe we need to check that we haven't exceeded a weight limit, you know, all kinds of other things. There could be all sorts of side effects to changing a property. And if changing a property does a lot of things and has a lot of side effects, then by convention, a lot of times you end up making it a function as opposed to just this setter property, because people are sort of more used to thinking that a function can have side effects as opposed to the setter properties, which you kind of just expect it to mostly just change that one property, that one value, and not do too many other things. But again, it's mostly just convention. And honestly, as much as possible, try to avoid having your functions have too many unexpected side effects if it's not particularly clear. Anyway, so that's that. And yeah, so that's good. What we're going to do in the next episode is we are actually going to deal with input and outputs, change things. We're also going to restructure this. We'll actually be introducing another class. Hell, I could do it real quick over here. I'm going to add file. We're going to add a new class, which we're going to call game, like this. And in fact, main, I'm going to take all this. I'm going to take all this part. I'm going to cut it out. And instead, in our game, that's where I'm going to do most of this work. I'm going to have the constructor, and then I'm going to have a public void run method over here. So what I want to do is in the constructor for game is I want to instantiate our player and our enemy, which are going to be private fields over here, or variables that belong to game. So a game has a private player unit and a private enemy unit. They get instantiated here in the constructor. As soon as you create a new game, then it will instantiate the player and the enemy, and when we hit run, it will draw them. Right now, only one time. And then their main, what we're going to do here is we're going to say game is equal to new game, and we're going to say game.run, create a new game, run the game, and then when we get here, the game is over. And this is typically what you want to do in your main function. Your main function generally doesn't do much more than just this. The advantage to doing this way is, let's say we want to start a new game, right? Let's say there's a restart that happens. Whenever game.run returns, that's the end of the game. But then we could just, over here, we could have this in a loop. We could create a new game and then run that new game a second time, which is exactly what we're going to do in the next episode. We're going to have the ability to play a game, have the game end, and then potentially restart the game without having to restart the whole program. But if we look at this, we should be exactly where we used to be before. I can run this. Same exact thing as we had at the start of things. But this is a very, very typical way of doing it. So we have these two private values here. So no one from outside of the game can twiddle with these values here, which is very nice and important. Keeps everything locked in. If potentially we're going to want to give things the ability to manipulate other units. For example, well, I'm going to have it later on in this game. This is a dodge game. When an enemy unit runs into your player, I want the enemy unit to tell the player, bang, you're dead. So there's going to have to be some sort of way to send those sort of signals back and forth, or for the enemy to get a copy of the player unit, or do something of that nature. But we're going to want to encapsulate that in some functions or some public properties or something of that nature, so that we can make sure that it's not being that we're not poking around things in the wrong way, in an inappropriate way. We don't want to poke things inappropriately. You always want to ask permission before you twiddle with someone's privates or... Okay, we're going to end this on that. Thank you very much for watching another episode, folks. As always, please don't hesitate to let me know if you've got comments or questions. I've gotten a few emails. I haven't responded to them yet, but they're on my to-do list. And so thank you very much for continuing to watch this and support the channel, and especially with the Patreon stuff. Cheers. Thank you. See you next time. Thank you to all our August patrons, i.e. people who pledged in August and who are supporting videos from September through to early October. And especially these Mic Check supporters. We got Ole Peter Talgo, Adam Conway, Drazion, Jan Torrevel, Adjective, Michael McClintock, Aaron Toyson, Craig Mortel, Julian Auger-Lafont, Marius Fieldvold, Speedy Savant, Steven Stager, Valiant Cake Fiend, Wes Oldenboiving, Jason Yanity, Kale the Quick, Neil Blakey Milner, and Yukofin, and everyone who's watched, shared, favorited, and subscribed. Thanks for watching. See you next time.